hard and soft rocks are sheared off the same, and sometimes at very low angles, like that. That takes a powerful current to do that for hard and soft rocks, leaving rounded boulders indicating it was water that did it. Powerful evidence that the Genesis flood really happened in the past. And there's a planation surface in the Little Rocky Mountains, north central Montana. What we observe today is planation surfaces being dissected, being destroyed. That's what we observe, not being formed. They formed in the past by some processes we don't see today. Powerful evidence of Noah's flood. Now, the evolutionists, the evolutionary geologists are well aware of these. They've been trying to explain them for well over 100 years. And C.H. Crickmay, I think, was the closest of any evolutionary geomorphologist to getting it right. But, because he was an evolutionist, that messed his thinking up. But he wrote in a book that's called The Work of the River. If you ever get a chance to read it, read it. But notice that Work of the River, scenery of the earth, river. See, water has shaped the scenery of the earth. He says the difficulty that now confronts the students, and by the way, he's not talking about college students. He's talking about anybody that studies the earth. Students, professors, lay people alike, anyone that studies the earth. He says this is the difficulty, that though there are plenty of hypotheses, they got lots of ideas on geomorphic evolution, there is not one that would not be rejected by any majority vote for all competent minds. In other words, there's not one that a majority vote would vote for. And he says that shouldn't be. We should easily be able to explain the surface of the earth. No, he says this situation is remarkable in a respectable department of science in the later half of the 20th century. It's remarkable. And you know why? He's got the wrong basis. Using the Genesis flood, putting on the flood glasses, and you drive around, you should see these things. Your children, I think, can understand the significance of these planation surfaces, that they can only be planed by a huge current, huge flood moving rapidly over, planing the surface to a flat planation surface. In summary, planation surfaces are common as erosional remnants. They're worldwide. They're difficult to explain by slow processes over millions of years. Now, I could say impossible, but I don't like to use that term, but I used difficult as the next best. Now I'm going to, at this time, I've usually run out of time, so I'm going to quickly broad brush water moving as channels. Now, I'm not going to talk about valleys because the evolutionists can explain valleys by millions of years of erosion. We can explain it as rapid channelized erosion to form valleys rapidly. I'm going to talk about some more exotic features of the Earth's surface that they can explain. Water and wind gaps, pediments, and submarine canyons. And I'm going to race through this. I'm just going to give you the conclusion. Now, you find these water gaps. Now, this is the Shoshone water gap near Cody, Wyoming, where this is the Rattlesnake Hills. And the Shoshone River cut a perpendicular gap through there. At least they think it did. 2,500 feet through hard granite and sedimentary rocks, when it could have easily gone around to the south. The river could have gone around to the south. Here's the Shoshone water gap, and here's the south. See, this is Buffalo Bill Reservoir. It's about a 100-foot dam. And look at how low it is there. When the valley was filled more with sedimentary rocks, it could have easily gone to the south around it. Why did it come straight out of Yellowstone Park and cut right through there? They don't know. They have hypotheses, but it's a mystery. And by the way, these things are all over the Earth, except maybe Antarctica. I mean, I bet you they're there if we can get that ice off of there. But I think the environmentalists won't let us take the ice off. Here's another water gap, 350-foot high, Sweetwater River at what's called Devil's Gate. Should have went around, but instead it cut through a granite ridge. Here are some, for your Easterners, this is the Susquehanna River water gap near Harrisburg, where the river cut through 4 ridges, generally in a meander like that, when it should have went around it like this. There's water gaps. One of the best places of water gaps around here is now, the Columbia River Gorge is not a significant water gap because that's probably the lowest area, so the water would have had to go through there anyway. One of the best water gaps in this area is the Yakima River from Ellensburg to the lower Yakima Valley, where it should have went straight east into the Columbia, but suddenly takes a right-hand turn and cuts through these lava ridges that are, what, 2,000 feet above Ellensburg, and cuts through it. I was just there, I think either yesterday or the day before, where we are developing a creationist road guide for eastern Washington and the Columbia Gorge and western Montana, the channeled scablands, that should be out in about a year, to give our interpretation of the geology. We're doing one for Yellowstone and the Tetons this summer. We've already done Yellowstone, and one's going to come out in about a month on the John Day fossil beds in Oregon. You can get these from the Creation Research Society. Hope Answers in Genesis carries them. But this is as you're going along, you can see our interpretation of the rocks. But anyway, that's an advertisement for that. This is a wind gap. I'm not going to get into wind gaps. But anyway, this is the Zagros Mountains. They have 300 water gaps there. And the interesting thing about them that they don't hardly follow valleys. Most of the time they go across barriers. It's really a strange situation. The Zagros drainage pattern is distinctive by virtue of its disregard of major geological obstructions, both on a general scale and in detail. Certain streams ignore structure completely. Some appear to seek obstacles to transect. Some of these water gaps in the Zagros are 8,000 feet deep, deeper than Grand Canyon. And where the river could have gone easily around it, it just goes right through it. Nature doesn't do things like that. The flood can explain it. How? Well, here's how I think it is. This is the conclusion. You had water going perpendicular to a rising ridge. And as all ridges are, there's low spots and there's high spots. And where it was low, the water started to take advantage of it and accelerate through it as some parts became exposed. And it dug the water gap rapidly, like this. And then when it was all over with, for some reason, this gap didn't erode enough and end up with wind just going through it. And this one, being the lowest spot, the river's going to naturally flow through that. So I think that's how it was formed easily in the flood. Now pediments. Pediments are those flat surfaces at the bases of mountains. Here's a typical pediment at the Tobacco Root Mountains in southwest Montana. These pediments are by the thousands in the Rocky Mountains. You see them in Arizona at the foots of mountains. There's a flat surface. You don't probably notice them. I mean, like me, until I put on my flood glasses, I'd look at the mountains. I love mountains. I didn't notice those things. But you know, they're all over. What's so distinctive about these things? Well, nature doesn't form flat surfaces. They're gravel capped, by the way. Here's one in the Ruby Mountain Valley of Montana. Here's the sedimentary rocks. They dip at a shallow like this, and the pediment cuts against it. And here's the rounded rocks on it. Those are called pediments. They're like planation surfaces at the foots of mountains. How do they form? Well, this time I think the water was going parallel to the rising mountains that were folding and cracking, and the cracks got eroded the fastest. And as the water was going down at high speeds down the valley, it was forming flat surfaces at the bases of the valley or the mountains, whatever, or ridge. And when it was all over with, you ended up with a flat surface called a pediment. That's how I think they formed rapidly during the flood. What about submarine? Oh, yeah, pediments. Here's a quote by a guy named Doran in Geomorphology of Desert Environments, 1994. He says, you see them a lot in deserts. Deserts are the best place to see them, but you have them in all climates. You have them in the Yukon Territory, a lot of places besides deserts. He says pediments have long been a subject of geomorphological scrutiny. Yeah, they know about them. They're not any big surprise. They know about them. Unfortunately, the net result of this long history of study is not altogether clear or cogent, and has not produced a clear understanding of the processes responsible for pediment development. Now, what is he saying? Now, as a weather forecaster for 30 years, I became a master of weasel words. And these are weasel words for we don't know. We haven't got the foggiest idea how they formed. I can recognize weasel words from one weasel to another. But I've since repented of my sin, and I'm doing penance by going out and talking about all this. Submarine canyons. There are canyons perpendicular to the continents that are very deep. The average submarine canyon is 3,000 feet deep, 50 miles long, but some of them are, actually a fair amount of them are deeper than Grand Canyon. One of them is 12,000 feet deep canyon. It's called, if I could pronounce it right, Zemchung Canyon on the Bering Shelf off the Bering Sea. And the Bering Canyon is longer than Grand Canyon. Here's how I think they formed. You had sheet erosion off the continent, formed the continental shelves. This isn't drawn quite right. I'm trying to get Dan Leith of Answers in Genesis to redraw it for me, but he's so busy doing cartoons for Ken Ham that I've been trying for. I think he's going to do it here soon. But anyway, see, you should see the sediments pile up first, and then the canyon cut, and it's cut as it becomes more channelized, and instead of depositing the continental shelf, it erodes a channel in the continental shelf perpendicular to the continents, like this. Here's another. Now this should form first. And by the way, these submarine canyons are sort of like a reflection of what you have on land, a valley. Here's a valley, and then you have a deep canyon off here. Just kind of a continuation of the current off land that continued on the continental shelf during the channelized phase of the flood. And here's what you end up with. Perpendicular, these submarine canyons, kind of with a valley, very similar, like a reflection of this canyon here. Now, they're unknown, too, how they form. Here's a report, one from Geology, the Journal Geology, 1998. At present, there are few studies of the processes by which submarine canyons are initiated or grow. And further work is needed to document how self-indenting submarine canyons form and how they interact with subaerially incised valleys, essentially saying we don't really know the origin of submarine canyons. And some of these canyons are cut into granite. Besides the shelf sediments, they cut all the way down through it and into granite. They're really very interesting features. In summary, major features of the Earth's surface can be readily explained by the retreating stage of the flood. Massive erosion leaves behind tall erosional remnants, planation surfaces, and long transported boulders. The eroded sediments form the continental shelf. Valleys, canyons, wind and water gaps, pediments, and submarine canyons form rapidly during the channelized phase of the flood. Mainstream geologists have great difficulty explaining all these features with their slow processes over millions of years model. All these features are worldwide, indicating a global flood, not a local flood. Therefore, there is startling evidence that Noah's flood really happened. And if you want to know more about this topic of geomorphology, it forms one chapter in the new book that just came out that I published, the Missoula Flood Controversy and the Genesis Flood. The point of this book is the controversy of why they didn't see the Missoula flood in eastern Washington. This is the potholes, by the way, the remnant of a 400-foot waterfall, and these are the plunge pools out of the dry areas of eastern Washington. Dry Falls, that's another one. But, these features are all over the place out there. The evidence is just overwhelming, and yet for 40 years they rejected it. Wouldn't even go out to look at it. Why? Because it was too big, too global. Because it was 400 feet going over Spokane, Washington, 400 feet going over Portland. It sounded too biblical, and that was the reason they rejected it. But when they went out there, it was as plain as day. And as a result, it shows you their bias. They got those blinders of uniformitarianism on, and they're not going to see the Genesis flood. So the point of this is I'm pointing out the controversy, and as a result, they're not going to see the evidence of the Genesis flood. And in the process, I talk about some of the latest stuff I and others have done on the Genesis flood and the question of time. Thank you.